As a consequence of unstoppable technological development and our quality of life, the demand for electricity has grown exponentially in recent years. If we add to this situation the need to draw on energy sources that are sustainable and environment-friendly, we can assert that it is of the utmost importance that we encourage a profound revolution in the management of electrical power. To achieve this, in October 2005, the Fenix project was set in motion under the auspices of the European Commission and launched with a budget of close to 15 million euros within the 6th Framework Program's Sustainable Energy Systems. A consortium of 20 partners from 8 different European Union member states form part of this initiative, including transmission and distribution system operators, manufacturers, business consultants, universities, and research centers. The objective of the Fenix project is to increase the penetration of distributed energy resources and its integration in the grid in a way that strengthens their contribution to the power system. This will improve sustainability of the network and the quality of service, will reduce CO2 emissions, and will lead to new business opportunities. In order to launch this project, revolutionary software was developed and is now being tested on a smaller scale before it can be put into use throughout Europe. The scenarios chosen for these field tests are Woking in the UK, hosted by EDF Energy, and Álava in Spain, hosted by Iberdrola Distribución Eléctrica, which were selected because they are representative of European networks and scalable to national levels. The expected results could be extrapolated to all of European society. Iberdrola, Spain's largest power company, has more than 10 million customers and operates in 14 autonomous regions, which represents about 40% of the electricity distribution business in Spain, is one of the partners of the Fenix consortium, and explains why Álava was chosen as a test area for the Fenix project. The presence of a big amount of already distributed installed generation capacity and a European average network, 2,000 kilometers of power lines with 70% of urban and semi-urban areas, attracted the attention of the consortium. In addition, Álava presents a clean cut between transmission and distribution networks. Anything done by Fenix at the distribution level will be clearly seen in 8 boundary transformers. A variety of players are involved in carrying out this test. Several energy producers using different technologies and sizes. CHP or combined heat and power, hydroelectric, solar, wind, and biomass. System operators. Red Eléctrica de España is responsible for the transmission network and Iberdrola Distribución for the distribution network. And the market operator OMEL, Compañía Operadora del Mercado Español de Electricidad, who basically organizes and regulates the supply and demand of electrical power in the day ahead. In addition, the Fenix project includes a new actor who will play a leading role from now on, the aggregator, whose mission will be to coordinate the various energy producers and to act as the intermediary between them, the market, and the system operators, in order to guarantee the proper supply of energy in both normal and exceptional situations that will be grouped in 4 possible scenarios. The aggregator legally represents a portfolio of generators and knows their situation in real time thanks to a piece of equipment called a Fenix box, which allows bidirectional communication between the DER and the aggregator. The aggregator knows in real time the status of each DER, but he also sends set points and commands to them. This new actor requires new tools such as DEMs that help him to perform all these functions. This opens a new set of business opportunities, such as consultancy and advice to his associates. In the day-ahead market, or the normal scenario in the power supply, the aggregator acts as an intermediary between all the parties involved within a perfectly coordinated system. Every day, The electricity generators contact their aggregator via internet to inform him of their predicted energy production for the next 24 hours. All the aggregators, in competition with conventional generation, inform OMEL and Iberdrola of their forecasts. The OMEL compares the supply and the demand and tells each aggregator the amount of energy the producers have been assigned to generate and at what price. At the same time, Iberdrola tells the aggregators whether the amount of electricity that their producers are going to generate the following day is technically feasible and ensures that it will not cause problems in its network. The distribution system operator provides the aggregator-validated program where the energy is sent and what offers are rejected. Likewise, the aggregator tells the transmission system operator, Red Eléctrica de España, how much electricity it is going to provide and through which node, so it can check whether the transmission network is technically able to handle that amount without problems. The transmission system operator, Red Eléctrica de España, uses the program created by OMEL to check if there is any problem in the transmission network. Iberdrola tells the aggregators whether the amount of electricity that their producers are going to generate the following day is technically feasible and ensures that it will not cause problems in its network. Once he has received this information from the OMEL and Iberdrola, the aggregator decides which producers meet the